Hey everyone, welcome to Robotics 101. Today's video is not going to be a project video, but instead a tutorial on how to make gears in Autodesk Inventor. And the reason why I want to make this video is because gears are really important for a variety of projects. They can be used in many different scenarios. If you're following my robot arm series, which you should if you haven't, you'll see that I'm using gears for many different parts of the robot, and it's extremely helpful. And also, I haven't really found any good gear tutorials for Autodesk Inventor online. A lot of the videos on YouTube, people are either drawing them by hand or they don't really explain the process by which they're making the gears. And while if you're experienced with Inventor already, this might be okay. If you're a beginner, this is really challenging to understand because I remember when I first started using Inventor, the whole the process by which I'm going to make gears, that whole thing, it seemed really complicated, and at first it was really intimidating. So I'm hoping that this tutorial can help alleviate that for most people who are starting out with CAD, and they can make some good gears. So let's get started by first creating an assembly. And once you create an assembly, you want to go to the Design tab and create a spur gear, because we're going to be using spur gears. And it wants you to save the assembly, so I'm just going to name this gear tutorial. And then this window should open up, and this is called the Design Accelerator component generator window. And pretty much what it does is you can input a bunch of different parameters, and it will automatically create the 3D model of the gear for you, which, as you can imagine, is really convenient because it doesn't require you to hand design it and worry about all of the nitty-gritties of the math involved with designing gears. So if you look in this first common tab, so pretty much this window is separated into common, gear 1, and gear 2. And that's pretty self-explanatory. Gear 1 is for one gear. You can choose that to be a component, a feature, or no model if you're only modeling in one gear. In this tutorial, we're going to be using 2 gears. And this common tab represents the parameters that dictate the values for both gears. The first thing, design guide, pretty much what that does is the tab, or the option you have selected, it prevents you from changing that for each gear. And what this does is it allows it to calculate it allows Inventor to calculate it based on your parameters. So if I choose something else like center distance, you can see that number of teeth is no longer grayed out, and I can change number of teeth. So I can change this to like 15 if I feel like it. And when I recalculate, you can see that the number of teeth for this changes and the center distance also changes. But if I go back to number of teeth, then I can change the center distance to be like 50, and I recalculate, and now both the number of teeth are changed. So that's the point of this of having this tab. Gear ratio is pretty simple. Gear ratio of 5 means that you're going to be increasing the output torque by 5, while decreasing the speed in most scenarios. So let's go ahead and actually generate these gears and see what they come out as. So you'll notice a bunch of things going on. First, you'll notice that the gears are at an angle, and then also that the number of teeth are corresponding to the number of teeth that we had in the design accelerator. So if we go back, we can see that the larger gear has 41 teeth, while the smaller gear has 8 teeth. Now, if we start changing some parameters, we can see how it affects the actual gear assembly. So if I increase the center distance from 50 to let's say 65, for instance, and I click calculate, you can see the preview changes, and now the green outline for the gears is slightly different. And when I click OK, it generates that 3D model, and now the center distance is greater. And now if you're wondering what center distance is, because I know when I first started out I didn't actually know what center distance was, a quick Google search will give it to you, but we can also see Inventor show that to us. So the center distance is exactly what it sounds like. It's the distance between the centers of the gears. And changing that parameter allows you to implement the gears in a variety of scenarios depending on what application you have. For my robot arm, my center distance is usually dictated by how much space I have and clearance, but you can change it depending on where you're using it. Another parameter we can change is the gear ratio, which is pretty simple. If I can change it from 5 to 8, and I click OK again, we can see that the number of teeth for the gears change. Now, obviously, you don't want the smaller gear to have not enough teeth, because there's a certain value where you want you want a certain number of teeth for the smaller gear, or else you end up getting problems when you're actually designing it, although it might seem to work in CAD. So let's put that back to 5. And by the way, this gear ratio is the ratio between the larger gear and the smaller gear, just to clear that up. Another important thing is face width. What face width is it's quite literally the width of the face, the 3D width of the face, and that might sound like an oxymoron, but as you can see, face width here is 20 millimeters. So if I go back and use the measuring tool, once this loads, you can use the measuring tool, and you can see that the width of the face of the gear is in fact 20 millimeters. So changing that, let's say you want a thicker gear or a thinner gear, you can change that and that'll help. So just to demonstrate, I'll change this to 10 millimeters, calculate, and you can see that for the smaller gear, it's now half its previous size. So I'll just change both to 10 millimeters. Now, if you were wondering how I got the gears to angle downwards, the parameter that I changed for that was helix angle. So the greater you increase the angle, the more steep the gears will change from face to face. So if I have this be 0 degrees, you can see that these just become normal straight gears, and these are known as spur gears, but when you add a helix angle, they become called as helix gears. And helix gears and spur gears have different advantages and disadvantages. I'm not going to go over the specifics in this video, but feel free to look them up. I'm using helix gears in my robot because I found that to be to make more sense in terms of my application. Pressure angle, pretty much what it is it determines how thick the gears, in simple terms, it determines how thick each tooth is. So I increase from 20 degrees to 50 degrees or 30 degrees, and you look really closely, you can see that, here, let me just wait for it to, you can see that now the teeth are more rounded when compared to before where they were more linear. And it's a really minute difference, especially when you're 3D printing gears, where it's not as accurate as machining them. It doesn't really matter. I personally haven't changed it, but that's just a feature there you can change. Another value you can change, and this is the last value I'm going to go over in the gear setup, is module. And there's a calculation for module. I think it's reference width divided by number of teeth equals module. And pretty much what that means is the width of the gear divided by the number of teeth for the gear will yield the module. And if you change the module and keep the width of the gear the same, you'll change the number of teeth for the gear. So pretty much what that means is when I decrease the module value from 2 millimeters to 1 millimeter, you'll notice that there's more teeth there's an increased number of teeth for the gears for the same distance. And what this means is now the gears are more fine, and you can have finer control over the movement of the gears. And this is helpful because if you're machining gears and you want really low backlash and high tolerance, and you have high tolerances, then this becomes really handy. But in my case, when you're 3D printing gears, generally 2 millimeters works just fine. But yeah, that's pretty much how it is. So now there's another tab for in the Design Accelerator called Calculation. And if I'm being honest, I'm not a mechanical engineer, so I don't really understand what a lot of these parameters mean. Obviously I understand power, speed, and torque, but if you notice, that's why when I click OK, it says that calculation indicates design failure, because Inventor thinks that I'm using these parameters with my gear design. But you'll notice that these powers are in the order of magnitude of kilowatts and stuff, and I'm using a NEMA 17 stepper motor, so my gears aren't going to be under that much load. So that pretty much wraps it up for this gear tutorial. I hope you learned a lot, and you can use these gears in your projects, and if not, you just learned something new, which is cool. Inventor is really cool, and it has a lot of powerful tools like Design Accelerator that I think is really important for me to cover, because I am a robotics YouTube channel and I didn't see anyone else have it. So yeah, that's pretty much it. Thank you guys for watching. Like the video if you liked it. Subscribe to my YouTube channel. Make sure to follow my robot arm series. I'm hoping to get more people excited about it and get the community involved. But yeah, thank you guys for watching, and I'll see you next time.